Well, welcome everyone to IoT and smart lighting platforms, the dramatic impacts and hidden opportunities of convergence. This is the second in a number of smart city sessions we're having this week. And I'm Jim Frazer. So at ARC, we've recently built out a smart city team over the last year. I'm Jim and I lead the effort. We have Eddie Fiedler, who focuses on transportation, rail, and smart cities. He's based in Boston. Epan is in India. He's our building automation focused analyst. Larry O'Brien, who many of you probably already know, is our cybersecurity lead. Alex Chatta focuses on smart buildings and particularly software platforms. Rick Risch covers the area of energy in terms of microgrids, photovoltaics, automated demand response issues and systems. Wasey is new to the company, and we're building out a rail practice. He's based in Munich. And Rob D'Angelo is our business development person. We've got quite a range of smart city sessions this week. We just concluded half an hour ago Smart City Platform Success Stories. We're at IoT and Smart Lighting Platforms. Later in the week, we have Smart City Best Practices, looking at what are the best practice approaches from the US DOT, from the IEEE, and other standards development organizations. Larry O'Brien has a session on the cybersecurity challenge for smart cities. Rick has a drones and their applications for smart cities. Late in the week, on Thursday morning, I'll be conducting mobility as a service platforms. You might get a free ride on an electric scooter if you attend that one. And we finish the week with smart parking systems, impacts and challenges. And lastly, I almost forgot, we do have an autonomous and connected vehicle test bed tour to the Florida Department of Transportation's autonomous and connected vehicle test bed right down the street, about half an hour away. So what is driving the smart city lighting market? Well, new technologies. We didn't have these communications technologies nor miniaturization 10 years or even 5 years ago. There's a convergence of technologies. Today, you might even have your communications processor in your power supply for your light fixture. So it's no longer two separate, discretely packaged components. There's a commoditization and standardization that's happening through in a lot of different areas that's driving down the price point, which increases the ROI and reduces the time of payback. Desiloization, particularly in the public agency marketplace, we're tend to moving, although it's happening a bit slowly. The silos are breaking down. In a city, for example, you might have the public works department looking at water. You might have the traffic signal maintenance staff that's a vertical in and on its own. You might have wastewater. Those are tending to be grouped together because of technology and the convergence of a single unified platform. And of course, the Internet of Everything. So in all you roll those all together, and that really is a pretty good look at an impact of digital transformation. So I'm borrowing this graphic from the Smart Cities Council. They've done a great job really in defining what is a smart city. And this graphic, it's a little small across the top, but they list 9 applications that generally are fit and cities or counties or even states are responsible for. So that's the built infrastructure, mostly buildings, fire stations, schools, city and county owned hospitals. The energy infrastructure that they might own, so that's in-meter billing, but it also might be the municipally owned utility, or even the rural electrical co-op for that matter. Telecommunications. So the the FirstNet responder communications for police and fire people, as well as the more typical communications within the infrastructure. Transportation systems, that's the traffic signals, dynamic message signs, all of that infrastructure, including light rail, city-owned buses. Water and wastewater, health and human services, public safety, so that's police, fire, EMS. Payments and finance is not one that you might lump in here. It might look a little different, but it also has some of the quickest payback if you do online bill payment. And of course, waste management, including things like waste to energy. So before I back up, so those are the vertical applications defined by the Smart City Council. Across in the rows are technologies that impact each one of those 9. So there's 7 technologies. And all of those really are encompassed in lighting control networks. So lighting controls, of course, do control. They offer connectivity. They offer some level of interoperability. And that's a topic we'll get into in a little more detail. Of course, security and privacy, data management, lighting control networks and smart lighting do backhaul all that data. And once you have it, you do need to manage it. You do also need to define your computing resources to do all that data mining so that you can derive some business intelligence and true, analytics. So what's the future for smart city platforms? Well, there's a plethora of sensors that are going out there in the world, particularly in public infrastructure spaces. There's everything from Bluetooth, traffic counters that are just put on a wooden pole with a photovoltaic panel and a battery to you name it. One of the biggest drivers is LED lighting itself. This really is magical because LED lighting for both indoor and outdoor applications is, it's well known now. It lasts 5 times longer. Your fixture now doesn't expire in 2 years. It'll last 10 or 15 or more from a maintenance perspective. But also, we all know that it saves 50, 60, 70, maybe 80% of your energy bill. Those higher numbers come with control systems. The magic, the untold magic, and why I have new in quotation marks, is that if you do adopt that LED fixture over an incandescent or fluorescent or metal halide or mercury vapor, 70% on average of that copper conductor is not used. So now on your street light that might draw an amp, your old legacy street light, now you're only using 300 milliamps. So you have now a free amount of 700 milliamps that you could use for anything you want. That could be Bluetooth people trackers, it could be Wi-Fi, it could be a 4G or 5G small cell, it could be cameras, it could be some other ITS equipment, it could be anything you want. So the interesting part is, guess what? That power infrastructure has already been paid for and amortized and depreciated a long time ago, but it's there for you to use. Transportation. Well, most of the shuttle company, the autonomous shuttle companies, while they will publicly promote themselves as people movers, and they promote that societal benefit, the real magic is that there's cameras on there and other sensors. So they really are in the market of collecting that data and monetizing it. So that they can perhaps tell a retailer how many times a logoed piece of clothing was seen on a particular street corner. Public safety. Cameras are everywhere, or optical sensors, as I learned they were called in my last session, are everywhere. So it could be from public facial recognition cameras to even to police body cams and everything in between. And of course, all of the sensors that are increasingly populating the downstream equipment for utilities within the substation, the high definition thermal cameras in the substation, down to monitoring nodes in PV, wind, photovoltaic, and microgrids and microgrid controllers for that matter.